Today, to access your bank account, you just have to go online instead of making the journey to a bank where there might be a long queue. However, to access your bank account, you need a password. What password were you thinking of using if you were only allowed to use numbers?
I want to use the password 1234567889.
I would not recommend using this password for your bank account. First of all, this is a very common password. Second, this password can be hacked in less than 1/5 of a second by brute force. Why is this the case? Let's look at the maths. There are 9 digits in your password and 10 possibilities for each digit, thus there are only 10 to the 9 possible combinations, or 1 billion. A hacker using ASIC can test 18 trillion passwords per second, so this password could be cracked in under a second if they knew it was only made of numbers. Let's see what happens when you have a password made of lowercase letters and numbers. What password would you use?
I want to use the password1.
This password is also really easy to crack. Your password is made up of numbers and letters, so there are 36 possible entries for each digit, and you've used 9 digits. So, there are 36 to the 9 possible combinations, which is about 100 trillion. As you can see, it can be cracked by ASIC in around 6 seconds. Now, choose a password of upper and lowercase letters and numbers.
I want to use the password1 with capital P.
This password is slightly better, but still rather easy to crack. This password is made up of numbers, uppercase letters, and lowercase letters. You have 9 digits, and each digit has 62 possible entries. Thus, there are 62 to the 9 possible combinations, which is about 10 quadrillion. This can be cracked by ASIC in about 10 minutes. Now compose a password of symbols, numbers, uppercase letters, and lowercase letters.
I want to use the password1 with an uppercase P and an @ sign for the A.
This is better than the last password since you're using the symbol. There are on average 96 symbols that can be used in a password, thus there are 158 entries per digit. You've made a password of 9 digits, then there are a total of 158 to the power 9 possible combinations, which is about 60 quintillion combinations. ASIC can crack your password in just over a month. This is much longer than the other password combinations. We've gone from having a password cracked in under a second to one taking over a month to crack. Let's look at what happens when you increase the number of digits. Choose a password longer than 9 digits with symbols, numbers, uppercase and lowercase letters.
I choose the password Richtig Piscina 529 @8!
That is a fantastic password. There are 20 digits in this password and 158 possible entries. Then there are 158 to the 20 possible combinations, which is about 10 to the 44. It would take ASIC more than 10 to the 23 years, or 10 trillion times the age of the universe. This password is strong since it's something you'll remember, it's long, and it's made up of numbers, symbols, and uppercase and lowercase letters. Now that you know your account is protected, how do you know that what you're doing on the banking website is also protected?
That is where public key cryptography comes in. There is a public key that everyone has access to. It is even possible to find the public keys of your bank. It is just a long string of numbers. Here is a public key of American Express. The public key encrypts information that can only be decrypted by a private key. The private key is held by only your bank so that the information is protected. The private key is mathematically related to the public key. However, it is extremely difficult to determine the private key from the public key. Why is this the case?
The public key, let's call it K, is a multiple of 2 prime numbers. There exists a function of these 2 numbers that gives the private key. So to find the private key, you need to start by finding these 2 prime numbers. This is a very time-consuming process. To do so, you have to check all primes less than the square root of K. Since K is a 1024-bit binary number, it is about 2 to the 1024, which is roughly 10 to the 300th. Then the square root of K is approximately 10 to the 150. The number of primes less than some number n is about n over the natural log of n. So when n equals 10 to the 150, there are approximately 10 to the 147 primes. Therefore, to factorize K, 10 to the 147 primes need to be checked. Modern hardware runs at around 10 to the 13 operations per second, so it would take 10 to the 134 seconds, or over 10 to the 125 years, for a person to crack that public key. Now you know how to make a strong password, and how you know it is safe to use online. Thank you for watching.